Optics deals with the phenomena involving light. So in optics what we did? We deal with the phenomena that involves light. The working of telescopes, microscope, colors exhibited by thin films, etc. Those are subject to optics, are topics in optics. Thermodynamics, so we have understood about optics as well. Thermodynamics, in contrast to mechanics, does not deal with the motion of the bodies as a whole. Rather, it deals with the system in microscopic equilibrium and is concerned with changes in internal energy, temperature and entropy. So this thermodynamics is mainly connected to internal energy of the system, temperature, entropy, etc. This we learn later, but for right now you can understand that this is mainly related to temperature because it is thermodynamics, something related to thermal of the system through external work and transfer of heat. So we transfer some heat or we did some work on the system, so it does deal with the temperature. How does that temperature will change? Because you know, suppose we have a system and this system is continuously running, so it will become hot. Why does this system will become hot? Why does this system become hot? So that we deal in thermodynamics. The efficiency of heat engines, so how efficient, that means how good are your engines and refrigerators. The direction of a physical or chemical process, etc. are the problems of interest in thermodynamics. So thermodynamics also tells us in which way a chemical reaction will proceed. The microscopic domain of physics, so till now we were discussing about macroscopic, that means mechanics. So how do the system moves and forces, so that is in mechanics. Electrodynamics, so how does the phenomena involving electricity and magnetism arise? Optics, phenomena involving light. And thermodynamics, that deals with the mainly with the temperature of the system and work done. Now let us come to microscopic domain of physics, deal with the constitution and structure of matter at the minute scale of atoms. So when we go to the scale of atoms and nucleus or molecules, so we go into microscopic domain. And even lower scale of lengths, so right now we are not concerned about lower length scales, and their interaction with different probes such as electrons, photons and other elementary particles. So when we deal with atoms, molecules, nucleus and etc. and their probes, what is probe? Probe is something using which we extract the information. Probe is something using which we extract some information, that is called a probe. So probes, electron, photons and other elementary particles. So that deals with, that microscopic section deals with these things. Classical physics inadequate to handle this domain and quantum theory is currently accepted as the proper framework for explaining microscopic phenomena. So as we have already discussed, classical physics does not work on this scales. So what we need? We need quantum theory. That means quantum physics to deal with this scale. Overall, the edifice of physics is beautiful and imposing, and you will appreciate it more as you pursue the subject. So overall, physics is a very good subject and you will appreciate it more as you go deep into this. So here one small diagram is shown. Theory and experiment go hand in hand, that means both work together in physics and help each other's progress. The alpha scattering experiments by Rutherford gave the nuclear model of the atom. So this is the picture where Rutherford is doing his famous scattering experiment by gold foil. So here is the gold foil. So this is a lead block and there is a polonium sample. So alpha particle is bombarded. Alpha particle is bombarded on this gold foil and this is a microscope, or we call it a detector. So this is detecting at which angle these alpha particles are going. This is called scattering angle. So using this system, he discovered nuclear model of atom, that means nucleus is at the center of this atom and all other space or all the remaining space is empty and electron is revolving around this nucleus. So that was the nuclear model of physics of atom. Now you can see that the scope of physics is truly vast, that means it is very big. I think this is one of the biggest sciences, definitely larger than chemistry. It covers a tremendous range of magnitude of physical quantities like length, mass, time, energy, etc. So it covers a lot of things. At one end, it studies the phenomena at very small length scale, 10 to the power minus 14 meter or even less. That means at the nuclear level involving electron, protons, etc. At other hand, it deals with astronomical phenomena such as the scale of the galaxies or even the entire universe, whose extent is of order of 10 to the power 26. So length scale is quite wide, from 10 to the power minus 14 meter to 10 to the power 26 meter. The two length scales differ by a factor of 10 to the power 40 or even more. The range of time scales can be obtained by dividing the length scales by speed of light. So if we divide this length scale by speed of light, so what do we get? We get this time scales. So length scale initially 10 to power minus 14 meter. What is the speed of light? 3 into 10 to power minus 8, sorry, plus 8. So when we take it here, so what do we get? We get 1 by 3 into 10 to power minus 22 and speed in meter per second. So meter cancels out, what we get? Second. So around 10 to power minus 20 seconds. Similarly we get 10 to power 18 second when we divide this 10 to power 26. Again the scale is huge, 10 to power minus 22 to 10 to power 18 seconds. That means very large time scale. The range of masses goes from say 10 to power minus 30 kilogram, that means electron, mass of an electron, to 10 to power 55 kg, that means mass of the universe. So in case of mass we deal with the enormous mass and very small mass as well. Terrestrial phenomena lies somewhere in the middle of this range, that means everyday phenomena lies somewhere in these ranges. So here we see length from nucleus to universe. Again time 10 to power minus 22 to 10 to power 18 second. Mass of an electron to mass of universe. We deal with everything in this subject. So this is truly a very big subject. Physics is exciting in many ways. To some people, the excitement comes from the elegance and universality of its basic theories. So for some people, what is the excitement? That it is applicable everywhere and it is elegant. That means how simple it is and that those simple things can be applied to very big things. From the fact that a few basic concepts and laws can explain phenomena covering a large range of magnitude of physical quantities. To some others, the challenge in carrying out imaginative new experiments. So again, imaginative new experiments. This is also an important part of physics. To unlock the secrets of nature, to verify or refute the theories. That means how we verify or say that this theory will not work. Refusal of theory is thrilling. Some gets joy into that. Applied physics is equally demanding. That means the physics where we do some applied kind of thing. Application and exploitation of physical laws to make useful device is most interesting and exciting part and requires great ingenuity and persistent of effort. So applying physical laws and to exploit them to make something useful is very exciting part of this physics and it needs a genuine effort. That means a full effort in which you give your fullest and persistence of effort. That means you continuously have to give your effort and this is some genuine your own invention. So this is about the physics, its interest and its areas.